Types of operating system.
There are types of operating system. 1. Batch operating system. 2. Time-sharing operating systems. 3. Distributed operating systems. 4. Network operating systems. 5. Real-time operating systems. First, batch operating system. This type of operating system does not interact with the computer directly. There is an operator which takes similar jobs having the same requirement and group them into batches. It is the responsibility of the operator to sort jobs with similar needs. Second, time-sharing operating systems. Each task is given some time to execute so that all the tasks work smoothly. Each user gets the time of CPU as they use a single system. These systems are also known as multitasking systems. The task can be performed as single user or different user also. Distributed operating system. These types of the operating system is a recent advancement in the world of computer technology and are being widely accepted all over the world. And the two with a great pace, various autonomous interconnected computers communicate with each other using a shared communication network. Independent systems possess their own memory unit and CPU. Network operating system. These systems run on a server and provide the capability to manage data, users, groups, security, applications, and other networking functions. These types of operating systems allow shared access of files such as printers, security, application, and other networking functions over a small private network. One more important aspect of the network operating system is that all the users are well aware of the underlying configuration of all other users within a network, their individual connections, etc., and that's why these computers are popularly known as a tightly coupled systems. Last, real-time operating system. These types of OS serve real-time systems. The time interval required to process and respond to inputs is very small. This time interval is called response time. Real-time systems are used when there are time requirements that are very strict, like missile systems, air traffic control systems, and robots, and etc.
Operating systems for mainframes. A mainframe operating system is a networking software infrastructure that allows a mainframe computer to run programs, connect link machines, and process complex numerical and data-driven tasks. All computers use some sort of basic operating systems or OS, which is what enables them to organize files and execute commands. Years ago, in fact, the terms define each other. A mainframe was any hardware system that ran a major IBM operating system. This meaning has been blurred in recent years because these operating systems can be run on very small systems. Unix and Unix-like operating system. First, Unix. Unix is a portable, multitasking, multi-user, time-sharing operating systems originally developed in 1969 by a group of employees at AT&T. Unix was first programmed in assembly language but was reprogrammed in C in 1973. Unix has been ported to more machine families than any other operating system. Unix-like. Unix-like operating system is one that behaves in a manner similar to a Unix system, while not necessarily conforming to or being certified to any version of the single Unix specification. A Unix-like application is one that behaves like the corresponding Unix command or shell. There is no standard for defining the term, and some difference of opinion is possible as the to degree to which a given operating system or application is Unix-like. Components of operating system. There are 6 types of operating systems such as file management, process management, I/O device management, network management, security management, and secondary storage management. First, file management. A file is a set of related information which is defined by its creator. It commonly represents programs, both source and object forms, and data. Data files can be numeric, alphabetic, or alphanumeric. Function of file management in OS. The operating system has the following important given activities and connections with file management. First, file and directory creation and deletion. Second, for manipulating files and directories. Third, mapping files onto secondary storage. And fourth, backup files on stable storage media. Second, process management. The process management component is a procedure for managing the many processes that are running simultaneously on the operating system. Every software application program has one or more processes associated with them when they are running. For example, when you use a browser like Google Chrome, there is process running for the browser program. The OS also has many processes running which performing various functions. All these processes should be managed by process management, which keeps processes for running efficiently. It also uses memory allocated to them and shutting them down when needed. The execution of process must be sequential, so at least one instruction should be executed on behalf of the process. Functions of process management in OS. The following are functions of process management. First, process creation and deletion. Second, suspension and resumption. Third, synchronization process. And fourth, communication process. Third, I/O device management. One of the important use of an operating system that helps you to hide the variations of specific hardware devices from the user. Functions of I/O management in OS. First, it offers buffer caching systems. Third, it provides general device driver code. Third, it provides drivers for particular hardware devices. And third, I/O helps you to know individual of a specific devices. Fourth, network management. Network management is the process of administering and managing computer networks. It includes performance management, fault analysis, provisioning of networks, and maintaining the quality of service. A distributed system is a collection of computers or processors that never share their own memory or a clock. In this type of systems, all the processors have their local memory, and the processors communicate with each other using different communications lines, like fiber optics or telephone lines. The computers on the network are connected through a communication network which can be configured in a number of different ways with the help of network management. The network can be fully or partially connected, which helps users to design routing and connection strategies that overcome connection and security issues. Functions of network management. First, distributed systems helps you to various computing resources. in size and functions. Second, they may involve microprocessors, mini computers, and mini general purpose computer systems. Third, a distributed system also offers the user access to the various resources the network shares. And last, it helps to access shared resources that help computation to speed up or offers data and ability and reliability. PIP, Secondary Storage Management. The most important task of a computer system is to execute programs. These programs, along with the data, helps you to access which is in the main memory during execution. This memory of the computer is very small to store all data and programs permanently. The computer systems offer secondary storage to back up the main memory. Today, modern computers use hard drives or SSD as the primary storage of both programs and data. However, the secondary storage management also works with storage devices like a USB flash drive and CD or DVD drives. Functions of secondary storage management in OS. Here are major functions of secondary storage management in OS. First, storage allocation. Second, free space management. And last, disk scheduling.
And that's all my video presentation. Thank you for watching.